All right, so looking at functional versus situational quadratics, what I want to talk about first is just what these words mean. Your function just means your equation. So when we're talking about the functional, we're talking about what does the equation say. Your situational is what's the story? What's really happening? Why are we using this equation to do? Like, what is it demonstrating to us? So if we look, an eagle sweeps down from the tree branch to capture a snake for its dinner and lands on another tree. The equation below can be used to determine the height h and travel time t of the eagle as it captures a snake and goes to another perch. So if we use our highlighters, your situation is this right here. This is our situation. They're telling us what's happening. It's about an eagle. He's capturing a snake. That's the situation. Your function or your equation is that guy right there. So if you see they've used our variables, this would normally be your y. It'd be 40x squared for the t minus 80x plus 40. They've given these variables names, okay? They've said that your x variable, where should we write? Your x variable is also known as t time. I know that's pretty small, but I want you to know that. Your y variable is also known as h for height, okay? Those are important. X and y are for your function. They're your equation in this case, so it'd be x and y. Your situation is saying that they mean t for time and h for height, okay? So that's the difference. You're taking mathematically and giving it a reason. Like, why are we using this? What's happening? Why are we what are we describing? So here's our picture. So it says, what's your independent variable? What's your dependent variable? So if we go back to our original x, y, Dr. ID, remember that our x values are also known as domain and independent variable. Your y's are the range, and now we're adding in the dependent variable. So independent and dependent are kind of new, okay? So it asks, what's your independent variable? So if we look, our independent variable, and then the dependent variable. Well, going back to what we said before, your dependent variable is the y. So we said our dependent is the y for height, right here. Height, h. And then your independent variable, according to XY Dr. ID, is your x. Your independent, we're saying the x is for time. So time, t. So then it says determine the domain of the function. So domain is my keyword. I'm keeping it with orange because it's part of the x values. They want to know what's the x value of the function. Okay, so function is just the equation. They want to know what's your domain of a function. Well, it's a quadratic. So looking at the quadratic, it's always going to be all real numbers. And then your range of the function, remember, is the y values. So looking at my y values, it's always going to be greater than 0. So y is greater than or equal to 0. But now it wants to know of the situation. So looking at my situation, the eagle started at 40 feet high. He flew down, got your snake. 2 seconds later, he was back in the tree 40 feet high again. So determining the domain, the x values of the situation, we're looking at your x-axis. So we need to remember he started at 0 time, which is time, right? Your x-axis in this scenario is time. So he started at 0 seconds. He caught the snake at 1 second, And then he continued on for 2 seconds to land back in your tree. So for the domain, he started at 0. So x is greater than or equal to 0, but less than or equal to 2. And what we should do is that should not be an x. We should say that it is t for time. All right, so the time. And then my range is that he started at 40 feet. He flew down to 0 feet to get the snake, and then he flew back up to 40 feet. And I know it's 40 feet, even though I can't read my graph very well. I know that my start value, the y-intercept, is 40. So he started at 40, but he did go down to 0. So your h is greater than or equal to 0, but less than or equal to 40. And we should probably put feet and seconds. So there is your domain and range of the situation. So now let's look at some additional questions. So how high was the perch that the eagle started? Well, your start was right here, also known as the C value. Okay, so where he started is your C, the y-intercept. So he started at 40 feet high. If it took 2 seconds for your eagle to land on the new perch, how high was it? Well, if he dropped down 40 feet in 1 second, he flew back up 40 feet in 1 second because it is a constant change. So that means how high was your new perch? It's also 40 feet. How long did it take for the eagle to capture the snake? So for how long is time, we're looking at our x-axis. And I know it's hard, but 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 0.1, or sorry, 1 point. So that means it is 1 second for him to get the snake. So what's the meaning of the 0 in this situation? Well, you need to remember that 0 means x-intercept. So the x-intercept from the graph means that that's where the eagle catches the snake. So what's the meaning of the y-intercept in this situation? So the y-intercept is where the eagle starts. And a little clue, your y-intercept in situations is always the starting point. So your y-intercept is always the starting point. So then, is it reasonable? Well, he started at 40 feet high. Is that a reasonable height for an eagle to start at in a tree? Yes, it is. He can start at 40 feet. An eagle can fly 40 feet, so that's a reasonable estimate.